Hello, and welcome to this webinar, Introduction to BIM Energy. Today, my name is Max, and I work here in BIM Energy as the Customer Success Manager. Today, I'm going to tell you a bit about BIM Energy and how you can use the program and how to get started. If you have any questions, feel free to write them in the chat or as a question, and I'll try to look at it and answer you as time permits. I don't think we'll take the full hour for just pure presentation, so we should have some time in the end for questions. I'll just start by introducing who we are, and then I'll start up the program. So we're BIM Energy, and we are part of Strusoft, a Malmö-based Swedish company from the 80s that was originally part of Skanska, but has been its own thing for many years now. Strusoft we have around 200 employees and customers and offices all over the world. And we also do multiple different softwares for the building industry. BIM Energy that we're going to talk about today, but also like some of you might have used before, BIM Design, Impact, VIP Energy, among others. And BIM Energy, it's a cloud-based energy calculation software. So it's all based on the web and no downloads needed. It's based on our earlier product, VIP Energy, that has been around since the 90s, but we wanted to make a more modern version that is easier to use while still keeping the proven calculation core. Customers and users is property owners, energy consultants, installers, architects, and others. And we try to make energy efficiency simple. It should be easy to do energy calculations, and that has been our goal with the whole program. And instead of having to do long, complex calculations, we want it to be easy to model their building, to try different things, to see and experiment in the building for quick, easy to understand answers. What happens when we do window changes and so on. We also have very accessible support. It's always easy to get in touch with us if you need any help. And this is us, the team behind BIM Energy. We're, as I said, Malmö-based, and we all sit here. The development team is also based here, and so is the support and everyone. So we always have quick ways to get in touch with people that's needed. That's very quickly about us. I'm gonna start showing you the program itself. So let's see. Here we go. So I just noticed that I'm having a problem with my webcam, so you might have seen an empty. There we go. Yes, this is the program. Like I said, it's all web-based, and I'm gonna do two different projects, and start by doing it one in Sweden, and then I'll also do one in Finland to show a bit differences. But so we'll first start when you log in, you get to this screen and you can create the new project. And you'll directly find the map to try and find your building on the map. And so instead of having to draw the full building or writing any numbers on the sizes and so on, you just click on the building on the map to directly get the footprint of the building with all the lengths and widths and so on. This was a relatively straight building, but it also worked on more complex buildings. And then you want to fill in when it's built. This is a building from 59, so pre-60. And you need to show you how many stories and is there any basements. This is a 4-story building with 1 basement, so that will change what kind of materials we're using in the building. So you see it goes also above and below, and how many the story height and also the glazing. So the windows, you can either write it in percentage or in square meters. And of course, you can do it in detail per facade. So you don't have to, you can either change it, of course, for all of the facade at once, but you can also go into detail to change it in more detail. And then we want to use what kind of building this. This is an apartment, so I'll keep on apartment house. What kind of ventilation? This is natural ventilation. It's a passive cooling and with district heating. But if you had a building using something else, you would change it here to get the results correctly. And you can also, in this case, I'm using the building year as the base of the what kind of windows, the wall thickness, the U values, but you can also base that on the construction if you have more detailed knowledge. We're also basing this on this is in Malmö because we clicked on the map and chose a building in Malmö, so we directly get the climate data from Malmö. This works around the world, so if you when we later have a building in Finland, this will be the Finnish data instead. So when I have finished all the settings, I create the building, and the program will do the first calculation. And then we get, what is the calculated primary energy number, energy class, and since it's a Swedish building, it's based on the Swedish energy class system. And also the calculated total floor area. And in this case, I know the building is actually slightly smaller than this, so I'll update this with the proper numbers. Since everything is based on square meters, you want to have that as correct as possible, of course. And now I can compare it to an energy declaration. The energy declaration put it as the primary energy number at 79, and I get, exactly that, 79.1. And energy performance is also within less than 1% difference, which means that the building is now close to what it is in reality. And since we have that, we can start the fun part, which is trying different things to see how it would change the building. So the first step is always to get the building close to what it is today before you start checking alternatives. I'll go into more details on the different parts of the program later, but we'll start by an alternative. I'll see what happens if I change windows. So now I'm creating a new building, which is an exact copy, except that it has better windows. The current U value of the windows would be around 2.7, with a new ones being 1.1. And when we create that, the program directly does a new calculation and see, okay, what would be the expected energy use in the new building. We have the primary energy numbers and the energy class that has been updated. Average U value is updated, and also what we have here, how much heat are we buying per year, which also gets updated. And so now, in just a few clicks, you already get the new building and an alternative. And we will go back to the current building to create a few different ones and then compare them against each other. And this time I would like to change to a heat pump. What happens if we install an exhaust air heat pump? So in our drop-down menus, we have the products as they are supplied by the suppliers. So they will all automatically have the correct information in them. But you can, of course, also add your own if you are using something else. I'll call this building heat pump so that we can check and remember which one is which and create alternative. And then I also want to check one building that has multiple combined changes to see how they work together. So I'll first go back to the current building and create an alternative, but this time instead of just one change, I'm going to add two of them. So it's windows plus heat pump. So I'll start with changing windows, and then in drop-down menu, I'll also add a heat pump. And to keep things consistent, I'm using the same one. And now you can see that, yeah, both of them have been added as measures, and I can create the alternative. Since I now have multiple different alternatives of the building, I would like to compare them to each other to see how they work together. So we go to compare in the left, and this will bring up all our different alternatives against each other to compare them for both energy use, but also the costs of installation and how long time it could take to payback time and other things. We're currently working in Sweden, so we're working in Swedish kronas, but you can change this to other currencies, whatever you are most comfortable using. And right now we're working with yearly prices of heating and electricity. You can also go into more detail, and you would like to change this depending on where you are, because of course prices vary a lot. Of course it varies not only depending on what country you're in, but also inside the countries. Here in Sweden we have very different prices in different cities. But for now I'm keeping them as the standard numbers. We also have the climate impact from heating and climate impact from electricity. And here we have the different scenarios. We have the current building with new windows, with a heat pump, and with both of them combined. So since we added them, the pre-made IDs, we can get in the pre-made alternative, we can get an investment costs. These are of course not exact. They are based on what we have been finding is reasonable for the different sizes. They're based on how large the building is, how many square meters, how many windows, and so on. So they're taking into account the actual building, but they are of course not as exact as if you go yourself and find what they cost. But they will at least give an indicative of how good or how expensive something will be. And based on that, we can see, okay, how much heating were we using in the current building per year, and what will our different alternatives, how much will it lower it? So if we take it under the windows, we can see that, yeah, it's around 80,000 kilowatt hours less per year. But if we install a heat pump, it drops down by over 300. But of course, the heat pump uses electricity, so instead we see that number jump up. But all in all, this will give us the costs per year of heating and electricity and the combined total, and also how much savings we get per year for doing the different renovations. And that will give us the payoff time. And we can also later, we can check these charts to see, okay, how much heating and energy, electricity are we using, compared all of them against each other, the calculated energy classes we can expect to reach with different renovations, and the savings compared to the total costs, and also the climate impact in CO2 equivalents. So it's very quick and easy to get an overview of how much a building can be improved. If you want to go into more detail of an alternative, we can also go to the report. So the compare step compares multiple different alternatives on a surface level, while the report is much more customizable and goes into depth. So now we see we're in the Windows plus heat pump, but you can also change to check one of the other buildings. And here I can see the detail of where does the energy come to the building and where do you lose the energy. So we have the heat gains from the sun, photovoltaic. We have the heat pumps, and the purchased electricity, the purchased heat, and so on. And we're losing it by transmission, and infiltration, ventilation, etc. You can also find the details, and if you want it in numbers, we have the energy performance and what results we can get, and we can also compare it to the Swedish BBR standards. And we're also working now soon we will introduce the Finnish standards as our next one, so that we can have and then we're working on getting global reach more and more. And this is very customizable. We have multiple different options depending on what you want to look at. You can get into details of the construction, of the surroundings, the windows, doors, the thermal bridges. So all the information is there, or you can also go into even more detail by adding your own charts that is calculated based on usage. And in standards, right now we're always checking as the latest standards. We update them as soon as they come out. Right now we're in BBR 29, and that is what energy class is from. But we can also check compared to older standards. And we have the heating. Since we started with using a heat pump, this is where you would check that, but you can also go on into the details. If you say that you're using a different product, you might want to change some settings, and with the COP value, for example, or the size of it, and so on. So it's all, you can go into very quick information, or you can go into detail depending on what you're looking for. And now I'm going to start up the next project to show that it works just as well in other places. I have an address in Helsinki in Finland. that I'm gonna show you. So again, I just find it, write the address and find it on the map. And here we can see the building gets selected. So we can just click it to get the shape. And it works on very complex shapes or very simple shapes. And you can also, if you prefer, if you see that, okay, it's not exactly like this, you can go into the edit mode and change it exact so that it matches exactly the building. Or if it's a new build, you might have to write, you might do it from scratch instead. And this building is 3 stories. On one of the facades, there is and there's no windows, so we're changing the glazing. And in this case, we're going to the detail and changing this to 0, so that there is no windows on this side, but still keeping the rest. We could also show it by square meters instead of percentage, if you want to go into more detail. Here, instead of using the building year, we're gonna be using the construction catalog. So this here we use the, if it's a heavy building or if it's a light building, like if it's wood, is it stone, and how insulated it is. So this is a poorly insulated light building. It's made of wood, and then we can view the construction that creates to start with. So this is how the exterior wall would be built. It's wood, insulation, and then wood. And we can get that for all of the different building materials. And this is exhaust air ventilation. So we're starting with that. It's still an apartment, and it's using district heating. And here we can see it on the map. We'll create the building, and let's calculate. In this case, since we're outside of Sweden, we will not get the standards by itself. That will soon be updated so that we can also use the Finnish standards instead. But it's something that's coming in our next update. But we can still, so instead we just check that the heat supply is correct, that the floor area is correct, and so on, and can do changes in the building to get it as close as possible. We can, for example, check into the construction. We're seeing that we're using a poorly insulated light building, and that means that this is the topology we're using. We can go into edit the topology to change one of them. So that, for example, I know that we have already changed the windows in this building, and therefore we're going to go with the triple glazed windows. That is much better, and save that one to get it up to what we have today. We can also check the usage, and here we can check the heating set points. This is what the calculation will always be based on, that if you have it 23 degrees, then the building will heat up to that level and try to not, or to never go below it. So if you're below, you'll buy more heat until you're up at it. So it's calculated dynamically by outside temperature, and these numbers are all changeable. So if you know that, okay, we're not using that much heat in the building, we only heat it to 22 degrees, then you'll update it, and the calculation will calculate based on that instead. You can also make schedules, say that, okay, and now I'm talking about an apartment building, so maybe you're always heating it the same, but if it's an office building, for example, you would want to heat it more during work days and less during weekends maybe, and you can also do the same with ventilation putting up schedules. So you can always go into very much detail, or you can keep it as a surface level. The calculation is always based on the reality, but how deep you want to go is up to you. And we can also create multiple zones in the building. If, for example, the first floor is apartments, or no, sorry, the store, and then the second and up is apartments, you can make changes, make zones, and separate them depending on that. And now that I have the building, I would like to again create some alternatives. So in this case, I would like to check what if we add in another type of heat pump. In this case, we're gonna use a geothermal heat pump to really use as a main heating source. So we'll add it, and then we'll decide if the peak energy would be based on district heating like it is now, or if we instead would like to use that as the electricity heating, but I'll keep it as it is for now and create the alternative. But since traditionally, of course, when you install a heat pump, your electricity bills will go up, even if your heat supplies go down. So in this case, I'm also going to create an alternative with a solar power as well to complement. And I can either go back to the current building and add in both at once, or I can go from the heat pump and create an alternative where I just edit, future edit to the same one. So this is, I'm adding some PV, and I can either work in kilowatt peak or in square meters, depending on what I'm more comfortable. Maybe I know the size of the roof and want to use that, or I know you have been talking with a solar power company and got an offer for a certain size. So this time I'm planning to use, okay, what if we use 110 kV peak and create that building? And then we create the alternative. So again, now we have multiple different options, variations of the building that we can compare. So we're loading up the different ones. And since in this case we're working in Finland, automatically it will be in euros. But again, you can always change this yourself. If you still want to work in SEK, you can change it there or in another currency. You can also disable the yearly prices or make any changes how you prefer to do it. So here we see that, yes, the electricity usage goes up, of course, with the heat pump. But therefore, we might get the synergy with also installing solar and seeing how much of that can we get. And this is including the exported electricity, which we can also go into detail about to see exactly how much we're exporting. So we go back to the building or to any stage really. And since we're currently in the building with solar, we can check here in the right drawer of photovoltaic power to see both how much it's used internally and how much we're exporting. So then you can use the program to find, okay, this is around how much we want to install to get a good balance of self-use and exporting, which of course varies from project to project how much you want to export. You can also go and say that no, we prefer to not export anything and just stop exporting. You can install a battery to go with solar power to get a higher percentage of self-use. And we can also go into the details of the photovoltaic cell, like what is the efficiency and so on. So you can always go into more detail. In some buildings, we might have a cooling need. In this case, we get very small losses from cooling, but if we say that, okay, we want to cool everything above 25 degrees, for example, probably not very likely, but just to see what it will do, you can see that it updates and we have a larger cooling need. And if we want to, then we can take care of the cooling need by adding in district cooling or cooling machine. We can also go into details of the ventilation to set schedules and every detail. And then you can also check month by month how much using you have. You can check the energy balance, for example, to see the results by month. And all of these is customizable, and then you can export it to a PDF to use it however you want it. We also, if we add in multiple buildings, we can go back to the project. Now I currently only have one building here, but we can go into the dashboard and find the building on the map to see how it works out. I'm gonna go for the Swedish one to show that one. Here we can see the building in context. If you have a large amount of buildings you have added in, you can all sort them by energy class and what you want to do with them to see which buildings are over and underperforming in an area. And this is the quick introduction to BIM Energy. It is free to try the program. If you're not currently a user of the program, you can go to our website, bimenergy.com, to try it for free. You just fill in the quick form and you will get a week's free trial. Or you can contact us. You can email or call us for any more information. And now I'm going to see if I have any questions. It don't seem like it at the moment. But I'm going to give it a minute before I close the webinar. It was quick startup today. If you want any more details about things, you're very welcome to contact me afterwards as well, and I'll be glad to help you out. Okay. Okay, I have a question here about the cost. It depends. We have a few different levels. Our Pro version is 300 euros per month, which includes basically everything I was showing today. We don't, let's see, can I pop this up to different plan depending on usage? No, we have I can show you here. We have plans that they include different things. So the one I'm showing today is I'm showing the full version, but basically our Pro version is everything except the dashboard, and then there are other functions that won't be included in the lower ones. The map, for example, that you can build from map is one of the features that we're including in our higher tiers, and multi-zone is another one. So our lowest, the basic, is only the You're not getting the comparison, and you're not getting multi-zone, and you're not getting the map. The Pro includes everything except the dashboard, which is mostly used by larger companies that have owns many buildings and want to. Okay, thank you for taking your time to listen, and I hope you have a good evening. And if there's anything more, feel free to get in touch with me. Have a nice day.